Hi, welcome to the first part of the Inspector URcap tutorial series. My name is Nils and I work as an application engineer here at SICK, and I'm the developer of this UR Plus plugin. In this part I will show you how to configure the Inspector URcap plugin to create a simple vision guided pick and place application for the universal robots together with our SICK Inspector PIM60 vision sensor. To perform the basic setup, there are a few simple steps we need to follow. First of all, we need to install the Inspector URcap plugin in the robot. Then we need to configure the Inspector PIM60 so that the robot can communicate with it. We then also need to calibrate and align the inspector to the robot coordinate system. The next step is to configure a reference object in the inspector with the object that we want to locate. Finally, we are ready to create a simple program so that the robot can pick an object using coordinates sent from the inspector. To begin with, install the UR Plus plugin in the robot. We do that by transferring the Inspector URcap to a USB stick and put it into the robot pendant. Then go to Setup Robot, URcaps, and click the plus button. Then we go to the USB disk and press the SICK Inspector.URcap file. Click Open, and then the robot needs to be restarted to finalize the process. While we do that, we can start configuring our inspector. For this, we need SOPAS ET that can be downloaded from sick.com. You can do that by following the link in the description below. So we start SOPAS. It will now search for the inspector, connect to the inspector, start configuring it. So we put it in edit mode. Go on the Inspector PIM60 menu and choose Interfaces and I/O settings. In here there are a few settings we need to make sure that they are set. First of all, we need to set Ethernet and Ethernet raw. We need to make sure that the web server is enabled, and in the web server tab make sure that it runs on port 80 and that we have allow changes via web server enabled. We also need to change some things in the Ethernet raw tab where we set it to TCP communication. Make sure that we have set allow changes via Ethernet raw and that STX and ETX are enabled, and also that the start port is 2114. We can now click on the apply button and the OK button and then set the inspector in run mode and save our settings to flash. By now the robot should have rebooted and we can go in and open the Inspector URcap plugin. To do so, go to Program Robot, Installation, and you should see the SICK Inspector installation node. Now we need to enter the IP address of our inspector. And make sure that the robot connects to it. When the robot is connected to the inspector, we can move on with the calibration and align it to the robot base coordinate system. However, before we can do so, we need to set up our tool center point, also called TCP. The tool center point is the center point in our tool here. And it's very important that this is set up correctly for the URcap to work. It needs to have its Z axis pointing straight down out of the tool. For the alignment, it's also very good to have a sharp pointy object in the tool and define your TCP position at the very top of the tool to get a good alignment. The TCP position I have already set up beforehand using the position wizard. I then know my tool is rotated 0.5 5 to 4 radians around the y-axis from the on-robot RG2 gripper plugin. When we are sure that the TCP is correct, we can go on and calibrate and align the inspector. To do this, we need a regular SICK checkerboard calibration target. These can be downloaded from sick.com in PDF format. You find the link for this in the description below. To start the calibration, we go into the SICK Inspector installation node and click the calibration button. First, we need to make sure that the robot is outside the field of view. Then we can click Start Calibration, and we then need to enter the size of our square calibration target. In this case it's 15 millimeters, so we enter 15 and then we press the Done button to start the calibration. This usually takes around a minute. When the inspector starts flashing again, we can continue with the alignment. To do the alignment, we need to set our TCP at these 4 crosses in the order of A, B, C and D. When you do this, you need to be as precise as you possibly can. So we start by the A cross and press the Done button. Move on to the B. Press Done. C, press Done. And finally D and press Done. Finally we press the Send Coordinates to Sensor button and get a calibration successful message. After having finished the calibration and alignment, we now need to make sure that we switch our TCP back to be inside of our tool. So we go to TCP configuration and choose our original TCP, set this as default and save the settings. We can now move on with defining our reference object in the inspector with the part we want to locate. To do this, we need to switch back to SOPAS. So we put the inspector in edit mode, we move our calibration target and place the object we want to locate in front of the inspector. Press the Teach Reference button, and now we will use the object locator tool. So we drag that around the object and try to set it as close around the object as you can. In this case we will also make a mask since the object is sticking up a little bit on this side. If you look to the right, you can see that the inspector calculates the settings for us, and we can switch to the live image to see that our object is located in the whole field of view. In here we can also change pick position, which is the coordinate that is actually sent to the camera. This is also possible to offset in the URcap, so we won't change that now. We now need to configure our Ethernet output string. To do this, we go to the Inspector PIM60 menu and choose Ethernet result output. To the left, we need to specify the angle type to be in radians, the unit to be in millimeters, and that the inspector should send aligned coordinates. To build our output string, we choose the object locator tool tag. Inside this tag, we then place a decision flag, the X, Y, and Z coordinate, and finally the rotation. We then need to have a comma and a space between the data fields. We just copy this and place it between the others. Finally, we need parentheses around the whole expression. We can now verify our output string and see that it looks correct. So this is the format that the URcap needs to receive the data. We need to have a decision flag to begin with, and then the X coordinate, Y coordinate, Z coordinate, and then the rotation. When this is done, we can click the apply button and the OK button, and we can put the inspector in run mode and save our settings to flash. The final thing we need to do is to create a simple robot program. To do this, go to the Program tab and click on the empty program. We start by adding a move node and setting our start waypoint. We can set that to be here. Click set this waypoint. We then go to the Structure tab and then the URcap tab to add a SICK Inspector URcap node. First of all, we need to teach the robot how to grip the object we have located. To do this, move the robot away from the field of view and press the Get Post button. This will give us the coordinates of the object that the inspector has located. We can then place the gripper above the object in the way we want to grip it. And press the Set Post button. The URcap automatically calculates the offset values for us from the position we get from the inspector. We can leave the move settings and speed settings and advanced settings as they are. We can now make sure that the robot actually moves to the correct position. Now we only need a few more nodes to make our simple pick and place application. So first we need to open the gripper. So we set the gripping width to about 40 millimeters. We then move to the object, and after we have moved to the object, we add another programming node to close the gripper around the object. So we set that to 15 millimeters. We then want to lift up our object a little bit, so we add another waypoint and we make that a relative position. So we can set the point that we are at now and then just move the robot up 50 millimeters. Then we want to drop off the object somewhere. So we add yet another waypoint, and we can drop off our objects here. Set this waypoint. Finally, we need to open our gripper, so we set it to 40 millimeters again. You can now test this program and see that it's working. So there we have it, a really simple vision guided pick and place application using coordinates sent from the SICK Inspector PIM60 to the universal robot. Thanks for watching this video. Please don't forget to subscribe to the SICK YouTube channel, and don't miss the other tutorials in the Inspector URcap tutorial series.